Thank you very much, madam. Namaste. Greetings from Peru. I'm very happy to share this international symposium with you. I'm very thankful to my dear friend Dinesh, who I met some years ago here in Peru, in the Cordillera Blanca. And it's an opportunity to talk a little bit about how things have been occurring in Peru during this COVID pandemic, and also what are our recent research in the high mountains in the Peruvian Andes. Uh, First of all, uh, as you may know, Peru has been one of the countries that has suffered most of the impacts of the COVID disease. We showed a high rate of deaths some months ago. And of course, this brought a crisis not only in the economy, but also in the social environment. Regarding mountains in Peru, we have the Andes, which are a very important socio-economic ecosystem. And although the deaths in the Andes, in the rural areas of Peru, uh, weren't high in the mountains in these areas, um, this area has been impacted, of course, in its economy, for example, as many speakers that preceded me mentioned. Their livelihoods and life are sustained in most cases, for example, by tourism, which has been restricted, of course, severely affected. But in some way, as you also know in your countries, these restrictions of tourism and of many people in the mountains have brought an opportunity, no, let's say, and a breath to mountains, to find a breathing space, of course. And this also brought us the opportunity to re-examine our notion of carrying capacity of mountain ecosystems, of course, how to apply management systems, better management systems in mountains, for example, as part of sustainable management politics. And of course, these are protected areas. For example, in Peru, in the Cordillera Blanca, we have the Huascarán National Park. To say that Peru has the 70% of the world tropical glaciers, so it's a very important area, and it's very sensitive and a very good indicator of climate change, of course. And we have been witnessing the retreat of glaciers for the last 40 years, and an important ice mass loss around 30%. And this has brought, of course, many changes that I will show briefly in the next minutes. But to say that, of course, local economy in the Andes, in the mountains, have been severely affected, of course, not only tourism, but also crop growth and cattle rising, of course, from small to big scales. And also, this has brought some problems because of restricted regulations and control in these national parks because of the pandemic. And of course, also research around monitoring, for example, water quality, environmental topics also have been restricted. So little by little, research is being again reactivated, no, since June, July, more or less of this year. in these areas on the mountains. And one of the points that also have been affected is the communication and education. No, so we are trying to build up again, and we are trying to restart all these activities that are so important for mountain management and also for sustainability. What I would like now is to show you briefly some slides of a project that we are developing since 2019 in collaboration with the University of Bristol in the UK. I don't know. Yes, here I have. We have this project, which is called the Cascada project. And in Peru, there is something unique that it's happening, and perhaps also in some other countries. And here we have had many speakers talking about biodiversity and the importance of mountains and how life start in the high mountains, of course. But in Peru, of course, as many other countries that are suffering from glacier retreat due to global warming, there's also something that we don't talk much about. We are most worried about the quantity of water resources, but not always about the quality of water resources. And in the Cordillera Blanca, what is happening? Let me show you. This project is about the cascading impacts of Peruvian glacier shrinkage on the biogeochemical cycling and acid drainage in aquatic ecosystem. The lagoon you see here, for example, is in the area of Huaraz. No, it's the capital city of the region of Ancash, where the Cordillera Blanca is. And as you see, it's a very nice scenario, no, landscape. But this greenish lagoon is around pH 3.4. So it's very acidic. And of course, it polluted all the watershed downstream, no? Let me see, okay. We all know this is happening around the globe. We are losing ice mass, of course, areas. Here, for example, the white, no, you can see is what we have left. And the other colors, grayish colors and black colors, are what have been lost in several decades, around the 60s until 2010, more or less. So there has been a very severe reduction in terms of area, square kilometers, along the Cordillera Blanca. And this is very important and has severe impacts, of course. For example, future changes in glacier export. You can see, for example, that in Peruvian glaciers, it's in a declining curve for water resources, but there is an increase, no, in flow stochasticity, and also always present geohazards that derive from these processes, no? And related to concentration, for example, of nutrients and other components, we can see that there's a rise and increase in dissolved organic carbon and nitrogen, of course, but there's a decrease in phosphorus. So there's a trade-off between nutrients, but also on metals that are being leached from the rocks, from metal-rich rocks, and that's the main point of this project. The Cordillera Blanca, as I said, is very important because it supplies a big population along the river Santa Valley as potable water for agriculture, cattle raising, hydropower, and it's the 40% of dry season supply for these populations, for these areas. But of course, because of glacier retreat, what is happening is that the metal-rich rocks and this metal-rich geological formation, rich in pyrite, for example, in sulfates, they are being oxidized by the effect of oxygen of the atmosphere. There's an intense weathering of the rock. So this is producing changes in the pH, is generating acidity. And this, of course, is the perfect way in which metals in the rock can be leached, and little by little they start to come into the headwaters, little by little, and then into the rivers, the streams, the rivers downstream, and representing a very critical problem for water quality, for these populations. So important rivers are becoming toxic, because of low pH and rising metal concentrations. The question is if still some areas of the Cordillera Blanca can provide a treat, as we usually know. For example, if sediments are carrying nutrients, carbon, nitrogen, phosphorus, etc., which are important, of course, for the biogeochemical cycling and for providing nutrients to soil, not only in the upper parts, but also in the areas where agriculture and cattle raising is developed, like in the mid parts, low parts of these watersheds in the Andes. But the thing is that besides treat, also toxin is occurring. And as you can see, for example, this is one of our saddest examples of the impacts of global warming. This is the Pastoruri Glacier, and you can see from 1986 to 2012 how we have lost a big ice mass, and this is bringing acid heavy metal deposits into rivers, sediments, and producing problems not only for the functioning of these ecosystems, but also to human health and to productive activities, and to, of course, the livelihood and also the support of economic activities that are important in this region. So there are many papers already talking about toxicity in the Cordillera Blanca, and you can see places where, but few, where we have some remains of old mining activities. There are mine dumps that have been located close to the Santa River, for example, for a long time, more than 50, 60, 70 years. And of course, they are leaching to the soil, also the river. But most of the acid production and metal mobilization is due to acid rock drainage. Let's say natural phenomena that it's deemed to be accelerated by glacier retreat to global warming. So what can we do in facing this problem? Here are more examples of toxicity of metals that, of course, their concentrations are far beyond the accepted limits by the World Health Organization and national regulations in Peru, for potable water, water for agricultural activities, etc. So what can we do? What's the hypothesis behind this? Is that, of course, this has been happening already for many years, long time, but we still want to see into how these ecosystems are able to provide buffering capacity, and why there are some places that have suffered of strong degradation due to acidity and metal mobilization, and why other catchments that are located in the same geological formation, which is called Chicama here in Peru, why some of them have in some way resisted to this process, and they keep like pristine still. So these are some of the questions we want to answer, and I think it's really important to harbor these questions and to bring potential solutions, because these problems will happen and perhaps will increase if global warming continues and if glaciers continue to retreat. So we want to produce in this project a map of vulnerability, let's say through different techniques, chemical, geochemical, of remote sensing techniques, etc. How can we predict which areas, which catchments or subcatchments in or basins in the Cordillera Blanca will suffer most and when from the impact of glacier retreat regarding the impoverishing of water quality, no? Let's say acidity and metal mobilization. So the overall aim of our research is to understand these processes, controlling water quality in catchments, so we can, as I said, predict water quality evolution in deglaciating terrains, and to develop effective solutions for toxic catchments through the study of wetland functioning, for example, like natural filters of metals and acidity. So the objective at the end, and this is this last slide, is to establish year-round dynamics of treat to toxin, no? But because we know that many sub-basins are transforming from pristine, no, from a treat process to a toxin process. They are becoming toxic because of metals and low pH. Treat to toxin evolution in end-member Cordillera Blanca glaciated catchments, no, enabling the inference of process controls. Also establish regional controls in this evolution, developing simple metrics that we can then provide to policymakers to assess catchment vulnerability, like these maps of vulnerability. And finally, engage people, social actors that are already organized around the management of these catchments in the Andes, social organizations, for example, dealing with environmental issues or managing their water resources, no, for remediating acidified metal-rich rivers in collaboration with local community stakeholders. So that's something we are doing now in Peru, and I would welcome any idea or thought later. Any collaboration is always welcomed, of course. And thank you again for listening, and of course the organization of this symposium for inviting me. Thank you very much.